let's start now. So guys, yesterday we discussed about the deployment modes. We discussed about ICE can be deployed in the standalone mode or it can be deployed in the multi-mode. Right, in a multi-mode it was like with the different personas. How many personas do we have currently on the ICE? Four personas we have. One is policy administration node, monitoring and troubleshooting node, policy service node, and PX grid. So if I deploy all these personas separately on a single machine, that will be called as a distributed mode, or you can say it as a multi-node. You can see here, multi-node ICE means here I'll have 4 ICE devices connecting to your network. And here I'll have a single ICE device with all 4 personas called as a standalone mode. Now we'll discuss about the NSS. What is NSS? See, Cisco has introduced a special type of hardware on which you can deploy the virtual appliance of your ICE. Okay. It means they have introduced a dedicated hardware, like you have a UCS server and all, dedicated UCS hardwares, right? On which you can do the virtualization. Same way, they have introduced a Cisco Secure Access Control System called as a NSS, and these are the series, or you can say the model number, 3600 series, and the model numbers are 3615, 3655, and 3695. 50% of a real time, if you guys go, you will find these NSS servers. So NSS is basically a hardware which is dedicatedly introduced for the ICE virtualization only. So for ICE, whatever the advantages or you need a kind of a hardware support, you will get it from this. Or else if you guys want to go with the dedicated ICE devices, you can go. These are the SNS specifications of your 3600 series appliances. Like you have the model numbers. I have shown you 3 model numbers right now. And these are the specifications. One Xeon processor, and you can see 2.1, 2.1, 2.1 megahertz. And the model numbers are different. 4110, 4116, and 16 again. 8 cores, 12 cores, 12 cores, 32 GB, 96 GB, 256 GB. So depending. Now let's say 32 GB means it's like minimum one ICE will require 16 GB RAM. One ICE, either in a standalone mode or in a distributed mode, 2.4 will require in a virtual appliance 16 GB RAM. So if I go with 32 GB RAM, means I can deploy up to 2 nodes. Here accordingly you can divide and you can understand. So let's say if I have multi nodes, 4 ICE devices, or let's say if I have a HA between the redundancy between the multiple ICE nodes in a distributed mode. So 4 nodes means 4 another nodes. So like that you have to think. So they have given the another specifications. Now ICE deployment modes. See, standalone with all the personas, distributed mode, single persona, or we could see the hybrid mode also. Hybrid mode is like having like 2 personas, having 3 personas. Yesterday we had seen, right? Like a specific virtual appliance having a 2 different personas only. Or if you want a device to active only with the 2 personas or 3 personas, you can work with that. So such type of deployment, you call it as a hybrid. In a real time, all these 3 deployments you will see. It's not like you'll see only the standalone or the distributed. You'll also see the hybrid mode deployment. So all these three are most important. So in an interview, if they're asking you what are the deployment models, right, not the modes, models of your ICE deployment, then what you can say, there are three models. Standalone, wherein all the personas will be there. What do you mean by persona? It's a service. Okay. So four major services you have on the ICE. So those who have connected in a class today, for them I'm giving a revision. I'm telling you something like what we had covered yesterday. So these personas are nothing but these are the major services. And under these major services, again, you'll have other services. So like a device administration, network administration, such type of other services also will be there. So you have to know device administration or network administration is a part of which major persona. Like that you have to know, right? So later on we'll come to know, slow, one by one we'll come to know all these, the deployments comes under which persona. Okay. So it's all about these personas, managing these personas either in the standalone mode, means all the personas on a single machine, single node. Single node means one device. Hybrid can be one or two, three. Distributed means it's all separate. All four personas are running on the separate nodes itself. Four major personas means four ICE devices. Either it is a virtual appliance or it's a physical appliance. Okay. Now, see, these are the how scalable your devices are. You can see like 2.6 version also introduced for your ICE, and for their, you can see the deployment wise in a distributed mode deployment. If I deploy with the NSS with a 3695 as a PAN and MNT, then what will be the maximum connected endpoints? Okay, you can see concurrently, I mean like concurrent sessions. It's not an endpoint maximum. It's not like these many endpoints can connect. These many concurrent sessions can be created. Correct. Now, depending on the model number for these personas. So depending on the persona, they have defined like what can be the concurrent sessions in a different deployment modes. So you can see in a different deployment mode, different numbers we are getting. In a hybrid mode, we are getting a different mode. So in a hybrid mode, I can see, I can make a combination of all this. Can you see? This is all about the hybrid mode. Now, I hope it's clear to you what's a hybrid mode, right? Standalone deployment. So in this way, I can see the standalone deployment. In a standalone deployment, we'll have all the personas. So each persona like PAN and MNT will have how many concurrent sessions like that they have introduced, right? See, monitoring and troubleshooting will not have any type of connections. Monitoring and troubleshooting is just like a reporting. So if I generate all the reports also on a single device, don't you think they are going to occupy some space? So for monitoring and troubleshooting, keeping a separate device, right? For PX Grid, like third-party integration or the same vendor integration also, if I use a single persona. So basically here, the major rules, like major rules, if you see, will be a part of like all are major only, but depends. Device administration, network administration, trouble monitoring and troubleshooting, right? PX Grid, as per your deployment and as per your requirement, it makes an importance to you. Okay. Scaling iServices agenda. It's like what further your ICE are capable to get integrated with. Now let's say your ICE device, based on the model number, it will have a limitation of the internal database also. It's not like if I have one ICE device, then I can create unlimited number of username and the passwords. It's not like that. Per device also, you'll have the limitations. Like one device model number, it might have like 3,000, 5,000, such type of the number of users that you can create. Now
So I
let's
just
say,
want
well,
to ask you something.
yeah,
Sorry to interrupt you. Uh, as we have discussed the model numbers, right? So I can see there we have two series, like 35 series and 36, right? So in this one, which is a virtual one and which is a physical one?
no, this was all about NSS. NSS is your hardware platform on which you are deploying the ICE. Okay.
Okay,
Now, if you see the specific model number,
but this SNS you are talking about is the secure network server, right? But that is a Cisco hardware device. On
correct,
top of that, we will install the ICE
ICE device,
image.
correct.
Okay, suppose if I don't have this SNS, so where do I
Hmm.
install? Can I install in VM or like
Why not?
hypervisor?
Now depends what platform you have. I can deploy the virtual ICE on cloud platforms also. You need to see the compatibility. You can deploy it inside the ESXi as well, hypervisor as well. You can deploy. Let's
Mm,
say I have a Dell server having the ESXi operating system. There also you can deploy. But most of the time, what can be the problem is like unsupported things. Dell not supporting some specification or the requirements of your ICE, right? So in that case, if you have the hardware also of Cisco and the operating system running on top of that, I mean like a virtual
uh,
machine running on top of that also of a Cisco itself.
so which means the
Now,
table you have shown that resources must meet by the third
yeah,
party hardware.
one thing, let me make it very clear. This NSS does not require any base operating system to run your ICE. That's a
But
major difference.
mhm.
When you talk about the other virtual machines, like if I talk about any Dell server or if I talk about any UCS servers and all, they require any operating system like ESXi and all. On top of that, you have to install. But NSS, not like that. Directly, I can deploy the ICE.
Mm.
We don't have a hardware
So
so that
so the base will be Cisco SNS. On top of that, we can directly deploy the
directly
Cisco
implement.
IC.
Correct. Or else
Okay.
you guys can go with the Cisco ICE hardware appliances. If you see, you can also say these NSS are a kind of a hardware device itself. You can say Cisco NSS, wherein we don't require any kind of extra operating systems. Directly, I can go with.
Mm. So I just want to confirm the 36 series is a hardware one and 35 is a virtual one. Is that correct?
No, 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 no. Wait. Can you see all currently? You can see all the Cisco ICE showing you with NSS only. So you can see the hardware platform. If you see, that's basically a on top of which we are having the ICE operating system. You can say right now they are giving with the NSS only. Okay. Now you can see Cisco NSS. When I search for the hardware directly, what does it show? Cisco NSS only. So these are the hardwares on which we are directly having the ICE operating system. Okay. And ICE is having a kernel operating system of a Linux. It's not having any other kernel. It's having the kernel operating system of a Linux. Okay. See, these are the hardware design of your NSS. So a specific design done for your ICE itself. So in this we have like different model numbers. I mean like different series we talked about. We have 100 series, and the model numbers are 15, 55, and 95. Let's see the virtual appliances. Cisco ICE virtual appliance, virtual machine dataset. Best thing you can do is check a data set. In a Cisco, you have a data set for everything. Virtual machine appliances, right? Okay. See, here I can see that they haven't given any specific type of, the number to your virtual appliance. What they have differentiated is based on the version. So based on the version, you'll have the virtual appliances. Like if you see, Cisco ICE software download, if you see, if you come here, what do you see? Can you see the OVF file? Can you see ICE OVF file? This is all about the virtual appliance. Okay, and this virtual appliance you can directly download. So there is no specific model number for your Cisco virtual appliance. You'll get the virtual appliances only based on the versions, right? So version like 2.4, 2.7, 3.0, such type of versions you'll get. Now, now let's say, for example, if I want to go with the hardware, then you'll go with the NSS only. NSS hardware deploying with the different model numbers, right? So this is what details we have right now. So for virtual appliance, you don't have any specific model numbers over here.
So both supports virtualization. 3.6 and 3.5.
See, one thing, let me make it very clear. NSS is a hardware, you can say, a hardware appliance of your Cisco ICE, wherein directly we have the ICE running. We don't need any kind of operating system. So it's just like a hardware. I mean, like you can say, like we have the ASA hardware, right? We have the ASA hardware box. On top of that, we have ASA operating system running. We don't need any kind of operating systems supported over there. So basically, you can say it's a physical box of a Cisco ICE, currently known by Cisco NSS. And virtual appliances, if I talk about virtual appliances, needs to be deployed on some UCS or NSX. NSX is different again. NSX is a operating system, right? ESXi is a operating system. Hypervisor, it's a kind of operating system of a, or you can say it's a, it's basically a, you can say it's a kind of a application, or you can say a kind of a service running on the Windows server, like Windows 2016 server on that you can have the hypervisor and all, on which you can do a virtualization. So such things you can have. So
Coming, okay, that is clear for me. Coming back to that distributed deployment mode. So in that
yes.
you can have multiple PAN, right? Means for administration.
So here, if it is asking here, if it is talking about the NSX mode, means NSS. If it is talking about the NSS, it means I'm having one NSS like 3695 NSS running with a PAN and MNT distributed mode, right? If I have two NSS, means I have two different hardwares running with two different types of personas, right? This persona, like that it is. Let's say here you can say like you have different hardwares. If I have two personas means I have sorry, if I have two nodes means I have two ICE devices, right? Like that.
So if we have multiple PAN in the distributed deployment mode, so like both will have the same database, or one PAN will handle a certain number of PSM, MNT, PXG, or
So depends like what type of task you are doing. Let's say PAN and PAN you are going to configure with the HA,
hmm,
right? So there is a HA configuration between two PANs. So both needs to have a same type of configuration, right?
yeah,
But if
EHA
they
is
are
fine.
not having a same type of, or they are not in a HA mode, in that case, what will happen? If they are
If you
in
see,
not in the HA mode means both will have a two different types of configurations, right?
okay. Hmm.
Okay, so I was talking about the scaling IaaS services agenda over here. Now let's imagine about the traditional network or the network wherein we didn't have the IaaS device from beginning. In that case, don't you think there was earlier also there was a user based or the identity based network accessing method? There was, right? By using Active Directory. Without Active Directory or LDAP services, you can see we have two services like Active Directory and LDAP. So Active Directory, like it's one of the service of your Windows 2000 server. The same way LDAP is also one of the kind of service available on your Windows 2000 server itself. So depends. Both are used for the identity purpose only. So depends. Mostly what we use is a Active Directory. Examination perspective, what is important? Active Directory. So is it possible that can we connect the Active Directory with your ICE and then create a policy on the ICE for those users which are present on the Active Directory?
Yep.
And such type of task you will get in examination. The most important part, they'll tell you to integrate the Active Directory with ICE, right? And they'll tell you to use that Active Directory user with the ICE. And for that user, you need to create a policy. Now, let's say some authentication authorizations we have to do with that particular Active Directory user. So how would you use that Active Directory user for device administration or network administration? Can be used with the Radius protocol or can be used with the TACAX protocol. If I want to manage the network devices with the privilege 15, so how would you tell the Active Directory user should get the tag of privilege 15 when you are getting access to any device in a network? Question mark. Because Active Directory is not giving me the tag of privilege 15. So that user, the Active Directory which is integrated with the ICE, and through the ICE, when I'm authenticating with the same user to a network device, my tag should be, I mean, like my privilege level should be 15, means full privilege. So how am I going to tell that Active Directory user is going to have the tag of privilege 15? That's a question mark. Such type of tasks you will get in your examination. Or let's say, I want to use that Active Directory user for the, like we have a different personas here, right? We have policy service node. So whenever I talk about network administration or whenever I talk about device administration, these two things will come under your PSN itself. Does not come under the PAN. PAN is all about policy administration node. I have a user, I need to assign a privilege, or I need to create a user to access your ICE device, to manage your ICE device. So those management part will come under the PAN, right? So can I use those Active Directory users for a PAN purpose? The answer is yes. Can I use those Active Directory users for a PSN purpose? Answer is yes. So depends. So for what purpose can I use the Active Directory users? So you should know, first of all, Active Directory integration will be there. That profile, you can call it under the PAN also. You can call it under the PSN also. Both the places I can use it. Further, monitoring can be done.
Same Active Directory users can monitor.
I mean, like monitoring is like if I authenticate through the ICE, then report will get generated. Generating a report is like monitoring. If I used any users to authenticate any device in a network, so I need to see the current connection, who is basically logged in right now. I need to see the current user status. That's a monitoring itself. If authentication failed, then where do I check it? Under the monitoring itself, right? So MNT and troubleshooting is like you have a separate part. Like troubleshooting can be used for multiple purposes. Troubleshooting can be used to know the commands which are available and which are not available on your devices. So we have a specific feature called as a configuration validator under the T-suite. Like I'm talking about one of the feature like configuration validator. Configuration validator is a kind of a feature which is used to validate the commands on your network devices. Now let's say while doing the configuration of ICE deployment on your network devices, you might require a huge commands. Now, how did I come to know that these commands are required? I got it from the monitoring and troubleshooting features. By using this feature only, I got to know. There is a configuration validator, one of the feature. I connected the ICE with the device through telnet session or SSH session, and I try to know what commands are available and what commands are missing. So like that, I can validate and I can find out what are the required commands. So there are different purposes for which we use MNT. So I hope slowly the concepts are being clear based on your services, right? So here PSN used for the, sorry,
Can you please repeat about that command set?
configuration validator.
Yeah.
So configuration validator will be like, now let's say, these things practically I'll show you, don't worry. Examination perspective, distributed mode, they are not asking you. They'll only ask you in the standalone mode. So how do you do all this stuff? I'll show you. Let's say, there's a configuration validator called as a part, okay, wherein let's say, for example, here you have a ICE device, and ICE device is connected with one switch. So I need to build a relation. I need to build a relation between ICE and a switch. एक मिनट, ऑनलाइन बहुत सारे बंदे हैं. So मैं आपको मैसेज कर दूं.
हाँ वो स्क्रीनशॉट भेज दो.
स्क्रीनशॉट भेज देता हूँ मैं आपको. अच्छा. Hold on, guys. You know, when NSS was not there, there was a specific model numbers given for the ICE. It was not based on the NSS earlier. Wait. Okay, done. Now let's say, for example, here I have a ICE device, here I have a switch device. Between ICE and switch, I need to create a connection so that if any host is connecting through this switch, then switch can take your request to the ICE. Simple, right? If any host is connecting here and this host wants to authenticate in your network, he wants to enter through the wired connection, then he will send a request to whom? To the switch, and switch has to carry your information to the ICE. To carry the information from the switch to ICE is called as a device administration. This part will called as a device administration. Now, in two different ways, I'll make you understand. Separately, I'll talk about device administration. In a clubbed way, also, I'm talking about device administration. Device administration. And let's say this PC wants to get an access through wired .1x authentication. Means he wants to connect to your network through the wired connection. Right. He wants to connect through wired connection. This wired connection will be basically called as a network administration. Understand what is this? This guy wants to connect to your network through the wired connection and he wants to get an access to the resources. Resources in the sense, here I might have in my network, I might have my internal server, my private server. I might have a private server. Okay. I might have other devices in my network, or let's say I have groups like sales group, I have admin group, right? And I have a guests group. So this guy might be a part of sales group, and sales group will have their own tasks to do. Daily he has to come to office, he has to connect, he has to log in, and he has to do his tasks. Let's understand in that way. So this guy, when he opens a PC, he has to authenticate himself and get connected to the network, right? So that he can get the portal page of his company and he can access his server or whatever it is, right? This is basically a part of network administration. I'm trying to connect into a network. My target is not to manage any device through the access. While connecting to the network, after connecting to the network, my target is not to manage any devices. Let's say, for example, here I have a router. Here I have a router in the network. My target is not to get access on this router or to manage this router. It's not like that. My target is to authenticate myself in a network and to get the access to the network resources, to get access to a internet, to get access to blah blah, any kind of access that I want, that I need, or sales related task he wants to do. So my policy is, my company's policy is, until you don't authenticate yourself, you won't get an access to any resources. Now another task what we can have, let's say for example, here I have one guy. Here I have one guy. He wants to directly get access to this router. He wants to manage the device. So wherever you see a kind of a device management part, that comes under your device administration, right? So this router and this ICE has to be connected. There should be a relation between this ICE and a router with a TACAX or a radius. So whenever he wants to access this router, router will send a request to ICE through TACAX or a radius to verify the identity. But in this case, what is happening? I am sending a request to the switch. Switch is taking my request to ICE through TACAX or radius. So don't you think the task which was done here directly while accessing is same kind of a task done between the switch and ICE? Radius and TACAX being used between switch and ICE. So it's just your vision, it's just your thinking. Like if I see the communication between switch and ICE, it's just like a device administration. If I see a situation between this PC and the router access, it is a part of a device administration. So wherever you see a device talking to ICE with a radius and TACAX, that particular part only you can call it as a device administration. Okay. Or else you can understand in this way, simple way. The guy wants to access a network device. This will be called as a device administration. And a guy who wants to authenticate himself and wants to get an access to a network is under the network administration. In these two ways you can understand. So a relation between switch and ICE will be done when you have configured the appropriate commands. If any commands are missing, then do you think they are going to communicate with each other? No. Now let's say this guy wants to authenticate via switch. At the switch port, some commands will be required. If it is a .1x authentication, .1x related commands will be required. Now, new guys might be confused by thinking what is .1x or what is MAB. Right now, you just understand these are the authentication types. In which way can I, authenticate into a network? Now, let me tell you what's .1x. If I say .1x is nothing but it's a identity based authentication. What type of identity? Username and the password. Username and password. If I use a username and the password, then I call it as a .1x. Right? Now, if I say MAB, MAB means what? MAB means what? What is the full form of MAB? MAC address authentication bypass. So what does it mean? MAC address authentication bypass. So whenever the device will authenticate it based on the MAC address, then it should bypass. Does it mean like that?
Bypass .1x.
It says bypass, nothing but it bypass .1x, correct. Bypass .1x. Means bypass username and the password authentication and do the authentication based on the MAC address. Now devices like webcam, devices like printer on which I want to control the access. I don't want everyone in a network should get access to a printer. Unnecessary, anyone will give a printer to a printer and he will get a printout. I don't want that thing to happen. See, your small device or a small loophole can create a big loophole or the attack into your network. can be through your printer itself. I can perform my attack into your network. Now let's say I'm working in a hospital. In a hospital, everywhere I have a cameras, right? Like operation theater, I have a camera. Different sections, I have a camera. So I need all the monitoring. Or let's say I have a section wise, guys monitoring are different departments. I don't want to give all the cameras access to one particular guy. This guy will handle the operation theaters cameras. This guy will handle the nursing department's camera or something like that. Patients department, something like that. I have practically seen this and deployed this thing in a hospital. That's why I'm giving an example of hospital. There they had to control those things. In a hospital, can you see how many multiple devices we have? Let's say if one device access someone if does the attack, if they gets access to a one operation device or something like that, do you think like what can happen? So basically I need a access to a devices on which I can assign a username or with username and the password, and I want to control those devices also on which I can't assign the username and the passwords. So technically, if I see, there are multiple devices on which I can't assign the username and the password. Few examples I gave you, like webcam, printer, like other devices we have. Now let's say in my network I have a router, or let's say you are connecting to my network. I cannot go with a MAC address binding every time, right? So I want to give you access based on the MAC address instead of authenticating based on the username and the password. Even PC, I can use it for MAB authentication. Or let's say based on your MAC address, I want to restrict some communications. See, whatever controlling you can do based on the .1x, same controlling you can do based on the MAC address also. No difference. If I can do the identity based authentication here based on the username and the password, and if you're thinking based on the username and the password only the controllings can be done, it's not like that. Based on the MAC address also you can do the same things, same controlling. Only the difference is here your identity will be MAC address and here your identity will be your username and the password. That's it. Rest all the controllings you can do. So when I was talking about configuration validator, see, all these things came from the configuration validator. So either I want a MAP PC to connect, or I want a .1x to connect, or I want a router to be configured, anything. Router to be configured with the ICE. So multiple types of devices or the configurations required. So on each device, what type of commands are required, that also I need to know, right? So configuration validator is a feature which we use between the ICE and a device to gather the commands. Now your configuration validator will validate the entire command of your switch, and it will tell you these commands are present and these commands are missing. You take a copy of that command from that output from the configuration validator, paste it in your notepad, edit it and paste it again to your switch. Such type of feature is that. Sometimes what happens, let's say you are in examination, you forget the command because you'll be in a pressure, you don't remember that command. Quickly you can use this feature configuration validator. If you are aware of that command but you forget that command by that time, right? Just use configuration validator, see the command and use it. Done.
Every command will be present.
Every commands on a Cisco ICE, to execute any type of tasks, whatever the commands are required, total commands for any type of tasks, all the commands will be shown by configuration validator. Either it is in a global configuration mode commands required or interface mode commands required. Everything will be shown by your configuration validator.
So this configuration validator is which comes under the persona of MNT.
MNT will be there, yeah.
So to get, suppose
Monitoring
I
and
have a, yeah, suppose I have a 3600 series device. Okay.
Mhm.
So do I have to input that device information to the MNT? Then only it will provide me the command set, because
Yes,
as you
you
know,
have to make a relation between the switch and the ICE. Okay,
oh, okay.
excuse me, guys, just a minute. Okay, sorry, guys. Uh, yes, so see, no matter what device you want to, on which device you want to gather the information, that device has to be integrated, means that device has to be connected with your ICE. So two different methods you will get, either telnet or SSH. These two methods you will get. Make sure that if you are connecting the switch, that switch has some IP address,
Okay.
because you have to telnet or you have to SSH. For that you need a L3 communication. So for L3 communication, you have to make your switch as a L3 device. Like that you have to do. So I need a connectivity, both the devices, connect with a telnet or SSH, and then get the commands. These things practically we'll see. Okay. So
So
this was what
the
I was,
configuration validator is only for Cisco platform, right?
yes, that is only for Cisco platforms. Now let's say, for example, I don't have a Cisco device. What to do? Can't I get access to a network? How? I don't know, right? Okay, I'll tell you. There is something called as a passive identity and easy connect. This is one of the new feature which has been added in your 2.x version. Easy connect. Easy connect helps you to connect to a network without any .1x, because .1x and the MAV is given for whom? For the Cisco devices only. On the Cisco devices, I'll configure a commands related to a .1x and the MAV, and then they will send a request, right? And they will get authenticated. But what if I have a non-Cisco devices, right? In that case, how do I connect? You can connect by using a method called as a easy connect. Okay. Guest management and a web authentication and location services. Guest management is just like someone who is coming to your network, right? Okay. Did you guys understand this easy connect?
Please repeat that once again, sir.
Sriram, I didn't get you.
So can you repeat? EC connect means that kind of, it's a kind of VPN access, right? Oh,
Don't relate it with any connect. Any connect is something else. Easy connect is something else. Okay.
so EC connect is for the third party devices.
Yeah, it's a for third party connecting to your network.
So
Okay.
what protocol they use to other than .1x? So EC connect is a protocol, or
See, it uses a protocol. I'm not sure about right now because we don't use Easy Connect as of now. Okay, I'll check about the protocol that we use through the AnyConnect. Okay, I'll tell you.
okay.
Now, we have a guest access management, we have the authentication, we have the location services. What are these things? Now, let's say, for example, in your network, some guests are coming and you need to manage their access for the guest. So how do you manage them? How do you give a limited access to those guests connecting through the wired connection or through the wireless connection? Right. Web authentication can be done in two different ways. There is local web authentication and there is centralized web authentication. Okay, LWA, CWA. Two types of authentications are there.
So LWA and the second one is?
Sorry?
The LWA and the other one is?
CWA.
What
Central web authentication, local web authentication.
So coming to the guest access, like what suppose because we cannot predict what device they bring, right? They bring their mobile phone or whatever it is. So which protocol, I mean, they use .1x or MAB to authenticate themselves?
Depends. Both can be used for guest management. Okay. Now, generally, what happens for CWA, Central Web Authentication, I don't have identity. I don't know who you are, right? How can I have your identity with me? Now, let's say, for example, you went to airport, right? I don't know your identity. Now, you want to connect to our internet. So what do you get? You get a one SSID. When you connect to SSID, one portal page is appeared. You have to fill the form to that portal page to generate one identity. So initially, to connect that SSID, you are connecting based on the MAC address. That will be called as a pre-auth. When you'll create an identity and when again you will authenticate, that will be called as a post-auth. Pre-auth, post-auth. Before authentication, you got means before authorization or before, I mean, like in a pre-auth condition, you just got a portal page wherein you could just get an access to the portal page to fill up the forms, not more than that. When you generated the ID, now that ID initially you got connected based on your MAC address. Later on you generated the ID that can be wireless.1x. Now that ID could be your passport number. ID could be your identity name itself or anything. You generated your ID. Now connect, or might be in that portal page itself, you get a username or the password or the, your passport number to enter to get access. So that passport number will be assumed as your identity because that portal will be connected to the database of your passport. So if you do anything wrong, you will be easily caught. So that is also a kind of a central web authentication management only. Okay, that's a best example that you can understand. Okay.
So this web authentication happened now after inputting the passport or mobile phone or name or whatever.
Okay.
So that section from the just device to the ICE device, what protocol are we using .1x there?
No.
Or some
see,
other?
I told you. First, I used a MAB authentication.
Correct.
Initially, to authenticate to a network, I used my MAB authentication. So based on my MAC address, it redirected to me to a portal page. Now see, two types of access managements are there. Either it can be .1x or it can be MAB. So most of the time you see the guest management is done for a MAB authentication only. No matter who is connecting to a network. So initial part, when you get authenticated, you get it based on your MAC address itself, right? Once you get the access to the MAC address, after that they tell you to generate the identity, or they tell you to directly input your passport number. So let's say if you are directly inputting the passport number, right? Now, see, two things you can understand here. You can say the initial authentication was happened based on the MAC address only, right? So that was a MAB authentication itself. You were redirected to the portal page wherein you had to add your device, you can say, or you had to add your identification. They might not ask you for username and the password. They would directly ask you for the passport number to get access. Another thing what might happen, they might tell you to connect the SSID, they might tell you to fill up the form to register yourself, and after that you have to enter that username and the password. So pre-auth, say I'm telling you two authentications are there. Pre-auth was MAV and post-auth was .1x, you can say. So you can say you authenticated, you created a username and the password, you entered that username and the password in the portal page, and you got authenticated, right? So there is a change of authorization, COA. There is something known as a COA. What is that? Change of authorization. So when change of authorization takes place, when you are entering from one to another, initially you got an access based on the MAC address, later on you enter your identity and get access. So there is a change of authorization, right? So basically it depends. Your web authentication can be based on MAC address also. 90% it is based on MAC address. Somewhere you see directly based on your .1x, wireless .1x or wire .1x. Both are possible. Also, you can track the locations. You can limit the services. Now, let's say I connected through SSID of the first floor, second room. So where am I? If I want to see that, I can directly see from where I have connected. I can easily find the location. After that, we have a compliance services, posture and MDM. See, this MDM is not basically used of ICE currently. It's not so popular. MDM is basically mobile device management. They have their own softwares for mobile device management. Compliance services and posturing, they use ICE. ICE has a good feature for the compliance and the posture. Compliance is just like when you are connecting to your network, I want only the limited things to work. Compliance, non-compliance, such type of things. You might have multiple applications in your PC, but when you connect to my network, you get only limited access. Posturing is just like checking the health of your device. Whether you're, let's say, to connect to my network, it's mandatory that you should have McAfee antivirus. And your McAfee antivirus should be updated according to my database, which is present in my ICE. Right. In a compliance, let's say, what else can be? When you are connecting your device to your network, your USBs are not working. Right? All things are getting disabled. So how these things are happening? These are all through the compliances. I don't want any outdated operating systems to connect to my network. That might be vulnerable. So how do I control that? I need to teach my ICE that any guest connecting with so and so type of operating systems do not give access. Such policies you have to create. Such type of things we basically called it as a compliance, and it's basically also a kind of posturing. Okay. TACACS design and scaling. TACACS, as you know, it's a kind of new database implemented, right? New protocol implemented in the ICE. Now it's not a new, but earlier it was a new itself. It TACACS was earlier used only in ACS. It wasn't used in ICE. 2.0 version onwards, TACACS has been introduced. TACACS is used for device management, centralized command authorizations, okay, profiling and database replication. What is profiling? Profiling is just like when you connect it to network, I'll come to know that you are your device is of which vendor, like Dell, or it's you know, let's say your every devices will have the MAC address, right? All the devices will have a MAC address. So MAC address, first half bit will be a part of vendor specification. ICE has a database of all the vendors. So based on their vendor's identity, if they are able to identify, then they will tell you that you belong to this particular vendor. That's a default profiling. Or else default profiling is done for a certain devices only, not for all the devices. Now let's say ICE has a huge database. Let's say it has a database of 200 vendors. But by default in a policy, they have included only 10 vendors. If you want to call any other vendors back to a policy, you have to manually do that. So basically ICE has a database. So whenever your device is connected, it understands that it is connected with which vendor. It is connected through wired connection or through the wireless connection. It is connected at which location, right? And it is using what type of application, all those informations will be there. Such information, gathering the information is all about your profiling. Okay. Guys, I'm sharing one number with you. On that number, you have to text and tell that you guys don't have any kind of dues. Okay. Okay. MNT, all these things we'll see slowly. Okay. Before I continue with these slides, let me tell you more about the ICE. See, ICE is completely a policy-based device, completely policy-based device. Anything that you do on the ICE will check with the policy. Two types of policies there are there on the ICE: system-defined policy and user-defined policy. So by default, what happens is based on your system-defined policies. And anything that does not happen, for that you create a policy, is called as a user-based policy. So two major types of policies you have: system-defined policy and you have a user-defined policy. So let me tell you where does those policies are present. Don't work with any lower versions or a higher versions. Work only with 2.4 version. Okay. Now here you can see identity service engines are collected through policies like authentication, authorization, profiler, or poster, right? So you can see the authentication policies. The authentication policies can be for device administration or can be for network administration. For a network administration, we have a different set of policies. like authentication policy and authorization policy. Can you see there is a policy tab, authentication policy, authorization policy? This is for network administration. For device administration also we have, right? Now, can you see here the predefined policy elements on the ICE? The predefined policy elements means what?
System.
System defined elements based on which your .1x is happening by default. You just need to do the configuration on the switches and your PC, and .1x through the radius happens, through the TACAX happens. How are those things happening with the ICE? Because ICE has predefined policies. The set of policies are pre-present, due to which all these authentication authorizations are happening. Those are basically called as a system defined. Can you see here? Under the policy tab, you have something known as a policy element. Under the policy element, what do you see? You have dictionaries, you have conditions, and you have a results. Now, under this, what do you see? You have a system defined and you have a user defined. And if you guys come to a system defined, can you see? All those things that supports with your radius or TACAX. I haven't given all the list over here. If you see all the list, if you go accordingly, I'm showing you. There you will see all the policies. Can you see the policy present for endpoints, internal CA, identity group, internal users, LDAP, right? Whatever we use for all these things, predefined conditions are predefined on your ICE device. So ICE is completely policy based device. Now, anything that is not working, and if you want to make it work, for that you have to create a custom policy, or you can call it as a user defined policy. So either you create a user defined policy or you work with the user defined policy. It's a completely policy based device. Like here you can see under the IETF, these many things are coming. Later on, you guys will see the use of all these things. Okay. Can you see like CHAP challenge, CHAP password? Right. Can you see the different vendors list over here? Aruba. Okay. You have HP, Juniper, Microsoft, well-known companies that you know. All the vendors' identities are predefined here. So it has a database. It can know your identity. It can do a default profiling. But apart from a default profiling, also, if you want some custom profiling to be done, for that you have to either configure or you have to enable the services which are disabled, which are not enabled, or which are not used in a policy. From the database, you have to enable it. Okay. So this is what we understand about the ICE. ICE is completely policy-based device. Everything is either predefined or you have to define. ICE can help you with a wired connection, can help you with wireless connection, can help you with a VPN, can help you with a device administration, or can help you with a context sharing. That's your PX grid. Okay. Now let me tell you a few things very separately. Apart from the document, we'll see and understand. I told you the two major functionalities of your ICE. ICE has two major things to do. One is network administration, another you have device administration. While doing a network administration, what methods do we use? In a network administration, what methods will come?
We have a dot one x and map.
Dot 1x. In a dot 1x, what will come?
Both wired and wireless.
Wired or wireless. This is called your network administration. After that, you'll have MAB. In a MAB also, what you'll have? Wired or wireless. You can see wireless cameras, right? Wireless printers. All those things can be controlled. Or they can be wired. Your printers are wired also, right? Your IP phones are wired also, right? So I can control those devices based on their wired connection or the wireless connection. So dot 1x wired or wireless, MAB wired or wireless. Or else I can connect to a network via a VPN. Right, here we don't have any kind of wired or wireless. That's through a tunnel itself. Coming to device administration, in a device administration, what do you have? How many types of a device administration, or which protocols can be used for a device administration? Can I use a radius for the device administration?
Yes.
Answer is yes. Or a TACAX plus. Now, with a radius, what type of device administration I can do? Or what level of device administration I can do? Till exec level of authorizations I can do with radius. Okay. And TACAX plus. I can use it for TACAX plus can be used for
Command level.
command label, exec label, and command label. Command level authorization will not be possible with the radius because there is a technical difference. There is a technical difference between radius and TACAX. Okay. I'm going to give you some tasks, guys. Okay. So your tasks are find a technical difference between radius and TACAX. Let me see how many of you can answer me. I need a technical difference between radius and TACAX. Don't do Google search right now. And can anyone tell me what's a technical difference? Let me see if you have any information on that. Because in CCNA, you had a AAA server, right? It's there in the syllabus. Okay. Any information on a technical difference between radius and TACAX?
Tech, yeah, TechAx actually perform the authentication authorization at the same time, but Radius, Radius will do at the same time, and
Yes.
TechAx will do individually.
More.
And other than that, they use different protocols. I mean, port numbers.
If I start telling means that will be answer itself. Then what research you guys will do? Hmm. TACACS earlier was a proprietary, but not now. Have you seen in a Palo Alto firewall there is a TACACS included? So if it is a proprietary, how come Palo Alto can use the TACACS? Earlier it was proprietary, like EIGRP. Earlier it was a proprietary. Now it's no more proprietary. The same way, TACACS is no more proprietary now, but earlier it was. But there is a technical difference. It's not about proprietary only. Proprietary in the sense it makes a difference when this TACACS will be used only on the Cisco devices. But now TACACS can be used with other devices also. So now that proprietary difference is not there, right? Paul, it's not correct. Accounting is also there with the Radius. Okay, with the Radius also you can see all the informations, all the records. Auditing can be done with the Radius. Okay.
Is that correct? TACACS does individual process of authentication and authorization.
Yes, that's correct answer. One major point I'm telling you, why Radius has the exec level authorization only, and why TACACS can do exec level and the command level authorization. Now, what is this authorization itself? First of all, you have to understand. Then only it will make sense to understand the difference between the Radius and TACACS, the technical difference. Radius does the authentication and authorization at the same time. In a single processing, it does authentication and authorization. And for accounting, it uses a separate port number. And in that also you have a legacy port number and you have a new port numbers. So what are the port numbers? What are the legacy port numbers and what are the new port numbers used by the Radius? Even that is your question, right? So when I say do research on the Radius and TACACS, then it covers everything. It's not like a 1 or 2 lines you will bring. TACACS does the individual processing. TACACS will do a individual processing for authentication, authorization, and accounting. Now that's the major reason why command level authorization is possible with your TACACS and it's not possible with the Radius. Radius will do authentication and authorization in a single processing, right? But I want the individual processing. So individual processing is only possible with the TACACS, not with the Radius. That's a major difference, right? There is other major differences also regarding the username and the passwords, the informations carried while TACACS and the Radius interaction happens between the server and the client, like clear text and encrypted. Such type of differences are also there between Radius and TACACS. So do some research. We are not in hurry to complete. Take your time to do some research on what's the technical difference between Radius and TACACS. The few points that I indicated, like encrypted and unencrypted traffic, or the information carried by TACACS or the Radius, that you have to check. Individual processing you have to check. Port numbers, protocols, details you have to check, right? Plus, this is enough as of now for you guys. And all these things, whatever we'll talk, we'll prove it practically also. Okay, so we'll capture the packet for the Radius and we'll see the differences. See all these details and let me know, okay, tomorrow.